Hey guys, welcome back to General Chemistry. Today we're going to continue our series of lectures talking about chemical reactions that you're responsible for. So just as a reminder, we've been talking about common chemical reactions where I could give you the reactants and you'd be responsible for knowing the products and then writing a balanced chemical equation. Today we're going to be talking about number 3, combustion reactions. For combustion reactions, the blueprint for the products and reactants is always the same. We're always going to have a hydrocarbon compound that burns in the presence of oxygen, and it will always produce the same two products, carbon dioxide and water. The only variable that we could possibly have in this reaction is this hydrocarbon right here. So hydrocarbon is exactly what it sounds like. It's a compound that contains only carbons and hydrogens and nothing else. Why can this be a variable? Well, we could have any combination of carbons and hydrogens. We could have 3 carbons and 8 hydrogens. We could have 10 carbons and 25 hydrogens. Really, we can make up any combination that we wanted to. So that's the only thing that could vary, and then what that would change is then the balancing of the chemical equation. The rest of this is always going to be the same. So we will always have oxygen as our second reactant. And we will always produce the same two products. We will always produce carbon dioxide, and we will always produce water. Writing or remembering the blueprint for this chemical reaction is not the hard part. Very often the hard part comes in balancing these equations that can get pretty tricky sometimes. So let's take a look at an example. Here I want to write a balanced equation for the combustion of C5H12. So the first thing is to get our chemical equation onto the paper. So our hydrocarbon in this case is C5H12. For a combustion reaction, it will always react with oxygen, and the products are always going to be carbon dioxide and water. Now the challenging part, balancing the chemical equation. So I'm going to take inventory of what I have and then start balancing this. So I've got 5 carbons, 12 hydrogens, and 2 oxygens. I go to the other side. I like to keep them in the same order. So I've got 1 carbon, I've got 2 hydrogens, and I have to be very careful with my oxygens here. I've got 2 from the carbon dioxide, and I have 1 from the water for a total of 3. Okay. All right, so now we want to start balancing this. Right away I see I've got 5 carbons on the reactant side, 1 carbon on the product side. So I'm going to say, you know what, I bet there's 5 molecules of carbon dioxide that form. So that's going to fix my carbons here. But what does that also affect? It also affects the oxygens. So again, we do coefficient times subscript. So now instead of 2, we now have 10 oxygen atoms from the carbon dioxide plus the 1 from the water. So we are at 11. So my carbons are balanced. Now I want to move on to my hydrogens. Wow, I got 12 hydrogens on the reactant side and only 2 on the product side. So probably this is going to have to be a 6. There's going to be 6 water molecules that form. So we take coefficient times subscript, and that's going to give us the 12 that we need. So now our hydrogens are balanced. But what does that also affect? It also affects the oxygens. So we still have the 10 from the carbon dioxide, but now we've got 6 oxygens from the water. And again, we're going to have to redo this. So 10 plus 6 is 16. So my carbons are balanced, my hydrogens are balanced. Now we need to take care of the oxygens. So on the product side, we're producing 16 atoms of oxygen, which means we need to somehow start with 16 atoms of oxygen. So that means we probably would have to start with 8 of these oxygen molecules. So coefficient times subscript, and we get 16. Okay. So I will tell you that these coefficients and then the number of each individual atoms, they do tend to get very, very large with these types of problems, and that's what makes them tricky. You're like, surely 16 oxygens is not right, but it is right. It is correct. So that's what makes these difficult. But that's pretty much it for combustion reactions. I hope you guys found this helpful.